All right. So, one point I want to tell you is that this particular question, I can answer this in one line, but I won't do that. We will spend a lot of time in understanding first. Unless I make you understand this, I will not solve this. The answer is very simple, but the concept is hard. So, focus on the concept first. This channel has 124 videos on alternating current. Please subscribe to this. Do not miss any of the videos given on this channel. Let's start discussing this solution based on conceptual knowledge. Thank you very much. Let's start discussing the concept of power factor. To do so, I will draw a diagram of a glass containing cold drink. Now, this is a very, very interesting explanation of using the example of cold drink and the way it is poured in a glass. So, let's talk about the cold drink and try to understand the concept of power factor using this. Thank you. There is a bottle here of cold drink, maybe, or a can, and the the cold drink is coming here and this is getting filled. What you will notice is that due to the gas, there is also formation of the froth, right? So let's say this is the froth which is getting created, right? The froth, which is the upper layer, a lot of bubbles in it, right? So let me change the color. So this is the cold drink, right? Which you had poured from here. This, if you notice, the lower part is your cold drink, right? The lower part is your cold drink. And the upper part is what? The upper part is a froth. Now tell me one thing, which is the useful part of the whole drink? You started with cold drink here. You started with cold drink, and then the cold drink got divided into two parts: the froth and the cold drink, which is a useful part. Obviously, the useful part is the cold drink. This is useful, right? This will taste like this is useful, right? So you would love to drink the cold drink, and froth practically, though is getting created and is like an evil. It does exist, but it is not useful, right? It doesn't taste like the cold drink, right? So it is pretty much useless, if I ever to use a strong word. So the froth is useless, but the cold drink is very good, right? Now, why did I explain you the concept of a cold drink to make you explain the concept of power factor? There is a reason, right? See, when electricity, which see the alternating current electricity, which you get in your home, when it comes to your house, okay, and you have, for example, you have a motor in your house, right? So the motor, there is something called as an induction motor, okay, induction motor. Now, your house also has a bulb, okay. Your house also has a tube light, okay. So, and there are many more equipment in the house. Now in factories you have a furnace, right? Induction furnace is there. Nowadays you have got induction cooker in the house, right? So different type of equipment exist in the house nowadays, and the equipment runs on what is called as alternating current. So all this equipment runs on AC, right? So that is known to you, that the equipment uses alternating current, which comes from the electricity board. For example, in Delhi you have BSES or Tata Power. Bombay also you have BSES, and Madhya Pradesh you have Madhya Pradesh State Electricity Board and all that. The the current or the power, let's use the word power, which is supplied to your house, is supplied to different type of equipment. The power which is getting supplied, right? The power that gets supplied, the power, why is it power supplied? Because these are the loads. Bulb is a load, induction motor is a load, tube light is a load. So when you hear the word load, these are the consumers of power, okay. They consume power, you have to pay for the power. So the power that reaches your house, also like cold drink, when it reaches your house, has two parts. One which is useful power, okay, and you pay bill for the useful power. The meters in your house are for useful power. This is measured in watts. And then there is a useless part of it. It is called wattless power. We will just call it wattless power. I will not call it useless, but let me use the word wattless power, right? This is measured in watts. This is also known as reactive power. I will tell you the difference between the two. And I said, just like cold drink has froth, which is not useful, similarly, the power also has a froth component, which is reactive power. The reactive power is also like froth. It is useless, right? It is no good. And why does reactive power come in? Because the load in your house, like motor, bulb, tube light, different loads have different types of properties. What do I mean by that? A bulb, for example, only has resistance in it. Okay, a bulb only has resistance. So whenever resistance is there, okay, the power which gets consumed is a useful power. Okay, if you have, for example, an induction motor, when the power comes in, an induction motor, so for example, this is your induction motor. The power comes from your electricity board. This is AC power. The induction motor, I'm using the word induction motor. When the power enters this induction motor, this is what will happen. Like cold drink entered the glass, it got split into two parts, right? So the power is now entering the induction motor and it gets split into two parts. It gets split into two parts. What part? This is part number one, which is useful. Okay. The useful part is the resistor part. Okay. So induction motor has two parts. It is made up of resistance. The second part it is made up of is inductance. Okay. L. R. Okay. So this is the division of power. So the power which goes to resistance is called as the useful power. The power that goes to inductor is the reactive power. Okay, reactive power. So this was a simple example of a induction motor which is getting the power. First part of the power is a useful power. The second part of the power is useless power. It is called as a reactive power. It is called as wattless power. These are the different names you give to it. Don't call it useless power. That's not the correct way. That was in the context of a cold drink, that the froth is useless, right? So this froth is useless. Similarly, this particular power which is consumed by the inductor is also useless. It is, the word uses, the inductor absorbs the inductive reactive power, but a resistor consumes electric power. Now you will say, why did I say that the inductor is useless? There is a reason. But before I tell you the reason why inductor absorbs the reactive power, and reactive power is very useless, I will tell you why. See, in the case of let me just tell you one more point. So capacitor, if a capacitor is also present in the circuit, right, in an alternating circuit, even the capacitor is a reactive load. It's a reactive load just like inductor. Okay. So capacitor also results in some wastage of real power. Okay. So what is your interest? Your interest is that the power which comes in gets divided into useful and reactive parts. What do you want actually? What you want in reality is that most of the power that comes in, most of the power should get converted to the useful part, and less power should go to this part, reactive power. You want most power to be useful. That is, most power should be used by the resistor. Like a cold drink, you would like that when you pour the cold drink in the glass, most cold drink should become the liquid, and very less cold drink should become the froth. Similarly, when the power enters the load, which is an induction motor has resistor and L both, what happens to power? The power sees the inductor. Some part of the power goes to the inductor. Some part of the power goes to resistor. The power that goes to the inductor becomes the useless power, and I will give you the reason why it becomes the useless power. We will come to power factor, but before you really start solving these problems, you need to understand the meaning of the word power and how the power is getting split in useful and useless components. So let's talk about the situation here. So the power comes in, the total power comes in. Okay, so let me draw an arrow. So this is your total power. Okay, the total power, and the total power is getting divided into two parts. Okay, one part is the useful part. So this is your total power, and this, for example, is your the voltage vector. So you know that alternating currents, the current and voltage are represented by phasors also. These are phasors. So the total power, and this is a reference phasor, which is voltage. The total power, so this component, so this angle, for example, is phi. Okay, let this angle be phi. The x component of this total power is the useful power. So I will write it as the total power P multiplied by cos phi. Right? The one, this is the hypotenuse, this is the base, it touches the angle. So this is cos. What is opposite to the angle? This angle is the artificial power or a wattless power. We can call it wattless, or we can call it a reactive power. Okay, this particular component is total power into sine of phi. I said the inductive power is useless. Inductive power or reactive power, capacitive power included, capacitive power, if there is only a capacitor in the circuit, it is also very disturbing if you have just a capacitor and a resistor. Generally, we would like most of the circuit to be made up of resistor, because it uses the total power which is coming in a very nice manner. Now what happens is, when the power enters the circuit, it gets split into two parts, the wattless part and the real power. This is called as a real power. Real power, the one which is used by the resistor, remember that. And this is measured in watts, right? The total power is measured in V into a VA, and the reactive power is measured as vars or kilowars. Okay, this is the way you measure. Now what happens because of the presence of inductor or a capacitor? See, I will discuss the inductor, because inductor is a real problem in our lives. What happens is, when the voltage is, that AC voltage is represented by this phasor, in a resistor, the current is in phase with this voltage. So this is your voltage and this is your current. They are in phase. But when you have inductor, so this is a circuit, you apply AC. This is a resistive load, RL. I'm using the word load. It's in ohms. The current which goes in, comes out, has some value. You can apply Ohm's law to it. The voltage phasor and I phasor are in same phase. They are in phase. There is no phase difference. What happens if this resistance also has a inductor with it? This is what happens in an induction motor. Apply the alternating current like this. This is resistance. This is inductor, right? Now what happens because of this inductor? What will happen is, the voltage is what it is, right? So voltage is like this. These two are in series, so same voltage. Now something will happen to the current in the inductor. The current in the inductor will be lagging now. It will lag the voltage by a certain angle, right? Now what happens? This is your voltage phasor. This is so whatever value which V occupies as maxima, current occupies its maxima in the inductor. So this chart, this diagram I'm making is of inductor. This diagram is for inductor and shows the relationship between V and I, and the relationship is that current lags voltage. Got it? So current lags voltage is the situation here. And the so supposingly what happens, you have a bigger inductor. If you higher is the value of inductor, this angle will go up. This angle will go up. As the angle goes up, so this angle will become more large, right? Let's call it a new angle, phi 2. Similarly, you can increase the angle further. What will happen is, so let me draw this, okay, example. So this is I cos phi. I am drawing the component of the currents now. So this is your current phasor. I'm using this particular one. And opposite to phi, it will be a perpendicular. So this will be I sine phi. This is a wattless current. And this current, the I cos phi, is the useful current or the real current. If you see, the real power is the V multiplied by I cos phi. So the two are in phase, right? V and I cos phi are in the same direction. But if you look into I sin phi and V is like this, and I sin phi is in this direction, right? So they're at 90 degrees. So the power which is getting generated or absorbed by the circuit is P is equal to VI sin phi. And I told you this is a reactive power. It is the useless power, VI sin phi, which we studied here also. This one, right? The P sin phi is a useless power. Now I'm expressing the same in terms of V and I. Same concept, same concept. This one was in power. So this was a power triangle, more of a power triangle that I made here. It's called a power triangle. The one which I'm making now is a VI characteristic. So here I've used V and I, and I've shown you V and I are in phase. This is the real power. V and I are at 90 degree. This is the absolutely the one which is the reactive power. Okay, the one which is in the inductor. It's because we started with inductor, and a induction motor which we were studying early. The induction motor we were studying is made up of resistor and a inductor only. Now you will say why this is again useless, right? It is useless because if the angle phi, higher is the angle phi, okay, if the angle phi keeps on increasing, which means higher inductance in the circuit. So keep the resistor fixed, keep on increasing the value of inductor L, get a bigger and bigger inductor, right? What will happen? This particular current will move in this direction. The angle is increasing, right? So a bigger inductor will result in movement of current in this direction. So if you increase the inductor further, the current will lag more. It will come here. Now let me show you the new angle here. It is increasing drastically. Let me show you the drastic increase in the angle. This is the angle being referred to. This is phi 3. The new angle. Can you see? If this is phi 1, phi 3 is bigger than phi 2 is bigger than phi 1. I'm referring to this diagram. So you can see phi 2, phi 3 and phi 1, right? This is the angle being referred to. I hope this is clear and making sense to you. So the bigger angle happens, because of a higher I. So L3, supposingly you apply 3 inductors, L3, then L2 and L1. So L3 is bigger than L2 is bigger than L1. Largest inductance results in largest angle. So the angle is becoming large. If the angle is becoming large, what happens to the real power? Look at this, real power. This particular value, cos phi, will become smaller. So a larger angle will result in reduction in cos phi. I hope this is making sense, right? I will just write it neatly for you again. So I'm saying if the angle reduces, phi reduces, if phi reduces, I'm giving you an example of inductive load. So therefore phi, if phi reduces, cos phi goes up. Cos phi increases, right? Because the angle phi reduces, cos will go up. Cosine value is highest for 0 degree, right? So cos phi increases if phi reduces. And let's look into this. If the cos phi increases, what happens next? The real power will go up because real power has an expression which is vi cos phi, right? So if cos phi is higher, the real power is high. So this is your real power. If phi increases, why will phi increase? Because the inductor value is more. The sine phi will increase, right? Which means what will happen? The value of vi sine phi will go up, which means the value of vi cos phi will go down and the value of vi sine will go up. So this is useless, right? Useless, totally useless. So higher is the angle, more you have a problem. The problem you will have is that a higher angle will result in low amount of real power because cos phi for high phi decreases. So cos phi decreases for high phi. And if the phi reduces, cos phi increases and sine phi reduces. So here the useful part is more and the useless part is less. If the phi is large, the useless part is high, the useful part is low. If I were to explain you pictorially, how will I do that? So you have this real power, the total power. So let's say the total power available to you is this. Now you can either have a very large base and a very small, the perpendicular component, which is the reactive power. So this is your reactive power, reactive. Okay, again back to the power triangle. This is what real power, right? Here the size of the power is constant. Say that this power is 1, 2, 3, 4, and 5, and maybe 6. Okay, first, second, third, fourth, fifth, sixth, 6 parts. Let me do one thing. Let me reduce the angle. What will happen? Can you see the base is increasing? The base is increasing and the perpendicular has gone down. So now the useless power is small and the useful power, this useful power is larger because the base, and this is the angle being referred to phi, right? Phi. Now let me do one thing. Let me keep the power as same but increase the angle. Let me increase the angle. What happens? The perpendicular becomes very large. The base becomes very small. What is the base? Base is always the real power, right? Look how useless. If the total power is coming and the angle is very large, what is happening? The real power is getting shortened. The useless power, which is this is the useless power. It has become so large. So it's a choice, right? You have a cold drink. What will you like to have? Would you like to have more froth or would you like to have more? What will you like to have? Let's talk about the cold drink example now, and we will then talk about power factor. But I hope it is making sense to you that having inductor type of load or capacitor type of load is a problem in the circuit because they result in creation of a lag in the case of inductor and a lead in the case of capacitor. The current leads in a capacitor. So I was going and talking about what? The example of the froth. So let me go back to this glass. If you have a total cold drink available, which is like total power, right? So this is your total power. What do you want? Do you want froth till this place? Right? Do you want froth till this place or what do you want? So this is your froth. You can have same amount of cold drink but more froth and less cold drink. Now what has happened? The cold drink has gone down, right? You poured cold drink, but what you got? You got less cold drink. Less cold drink. Whatever was in the bottle, but more froth. The froth is useless, right? It is, you have to wait for froth to settle, and the gas also goes away. Similarly, you can have a choice that you pour the cold drink in such a manner that the froth, goes down less, and there is more cold drink. Say here, right? I am now increasing the cold drink. So this is your cold drink, and this is your cold drink. This is your cold drink, and this is your froth size has gone down. The total volume in the bottle is same, right? It is still 80 cc. For example, it's an 80 cc bottle. Now you have 70 cc useful and 10 cc useless. The other situation can be what? Other situation can be that you have, I remove the cold drink and I increase the useless part. I still pour 80 ml, and this is what happens. Let me just complete the diagram. And I poured the cold drink, but this is what happens. This is your so it was 80, right? So let's say now this becomes 50, the good useful cold drink. This is the useful part. 30 cc is the useless part. Same amount of cold drink. Similarly, in power, when power comes in, the useful and useless parts matter. And what decides that how much power will be useful, how much power will be, the useful power or a useless power. If you go back to the discussion, what is deciding the usefulness of the power? From what I just told you by way of examples of these hypotenuse, if you note very carefully, what is deciding the power is this angle. This angle actually controls the size of the base, right? Higher the angle, smaller the base, low is the real power. This is the angle has gone down. The angle has gone down, and if you see the angle has gone down, the useful power has gone up. The useful power has gone up. This base, right, has become very large. So the phi angle is a very good controlling thing that controls the value of the how much useful power will be generated out of the P, how much useful will be there, and how much useless will be there, right? So useful part and the useless part, how does it get decided? It is decided based on the phi. And if you see the formula of the power, P is equal to VI cos phi. Really speaking, the P, the real power, right? The real part of the power is this, the cos component, which is this, right? In the direction of the voltage phasor, this is I cos phi, right? So the real power, if you see, is decided by cos of phi. Phi decides the split of power between the real power and the apparent power, so to say. So this is your useless power. Some people call it the apparent power also. Okay, apparent. Or they can, okay, let's not call it apparent now. Let's call it reactive power only. Okay, so they call it reactive or useless or wattless. Okay, wattless. And this part is, so if you notice, the real power, which is the base is always controlled by the cos phi. So smaller is the phi, better it is, right? We want a smaller phi to get a higher real power, which means we want more resistive load to be generated. We want to support resistive type of loads, and we pay the bills also for this, for resistor. For inductor, you need a separate type of meter to measure how much inductive load is being consumed. In our houses, we don't have these meters. We only pay for this power. So if power is coming to you, let's use the power properly and convert most of the power to the real power, right? And therefore, it is important to control this particular expression of cos phi. So cos phi is called as the power factor, because this is the factor which is going to control your actual power coming in. If it is high, it's a good power factor, which is around 0.7 and above, you will get good utilization of the power which is coming in. The power which is coming in is splitting into two parts: real and artificial, or so-called wattless. Cos phi is for the real part. What do you want? You want most of the power which is coming into get used in proper work, right? Useful work, not in useless work like inductors. It is useless completely. So you would like this situation, right? You would like, this is the best situation for you because the power is the same. Hypotenuse is same everywhere, but the base is very nice because this is the useful part. So how the useful part is being controlled? By phi, and actually by cos phi finally. So if you go back to this question, the expression vi cos phi, and if you, let's read the question, the multiple choice question which I started with, and I told you I will not just blindly solve the numerical unless I make you understand the concept properly. The phase difference between current and voltage, and when they say phase difference, they mean the voltage is here, right? The voltage part is here. So the lag, the angle between them, this is your voltage. In the inductor, the current lags. In the capacitor, the current leads. But the angle which is between the voltage and current, okay, this is inductive current, this is capacitive current, and this is the resistive current, because this is the useful side of the power. This is the total current, sorry, the inductive current, which is lagging. Okay, now it says the phase difference between the current and the voltage in AC is theta. Then what will be the power factor? If the, you know that this angle which is between current and the voltage is a very deciding type of angle, right? It decides quite a lot. So this angle which is between the current and the voltage, right? You see this angle, this particular angle, the one which is being drawn here, this angle has tremendous power. And this angle, cos of this angle, the cos of this angle is between voltage, which is in this direction, and the current, which is lagging in the case of inductor and leading in the case of capacitor. The cos of that angle is called as the power factor. So first of all, find the phase difference. What is the phase difference? When I say lead, the current leads. So automatically there is a phase difference. The current is leading. In the case of resistor, what is the phase difference? 0, because the current and the voltage are in same phase. In an inductor and a situation, the voltage and current are like this. In a capacitor, the voltage is here and capacitor is here. Voltage and this is current, it leads. This thing is called as phase difference. In the case of resistor, the phase difference is 0. Okay. So what is power factor? The useful part of the power is largely decided by the phi. The power factor will be given by cos of the phase difference. So my idea was, I could have told you this whole thing in one line. Answer is cos theta. But I want really that you understand the concept. If you have understood the concept, next time we will do numerical on this. In my playlist, you have 124 videos on the topic of alternating current. Please do not miss a single video. Go through every video, highly concept oriented, explanation oriented, reasoning oriented. You will learn a lot from these videos. 124 videos only on alternating current chapter.